Hello everyone and welcome back to my channel. So some of you guys may know that in the past week I have been staying in Pennsylvania in a power museum. Since I enjoyed chatting with volunteer engineers during my visit, there's no chance for me to make any introduction videos for some interesting engines. But hopefully during my next visit and volunteer in the next month there, I might have some time to make some small videos. So, today I would like to show you some interesting engines I have found in that museum. In this way, by showing you individual pictures or videos. So, before my visit, actually on that morning, I met with a guy who enjoys engine crafts and he repairs big trucks. Since I bring some of my nozzles and measuring instruments with myself, I showed him about this big injection nozzle and we have a nice chat in the hotel. So the first few engines I have seen in the museum, actually it's Mr. Kobe introduced them to me. And they are actually the very early stage internal combustion engines, which utilize an external flame source for the ignition of the mixture. Of course, they operate by following the Otto cycle, but they actually burn a mixture of hydrogen and air, or like 80% of hydrogen plus 15% of propane. That's the fuel they consume. And such engine utilize a slide valve for the sealing of the combustion chamber and for introduce the external ignition flame. So this thing, okay, let me grab a screwdriver. Okay, so this chimney here is where the external ignition flame source sits in. It's pretty similar to a hot bulb engine, the blowtorch, but in this engine, the external ignition flame here need to be burning all the time when the engine is operating. This spring-loaded thing is actually for pressing the slide valve, which is this part. You could see. Okay, just let me adjust the position of the picture. Okay, it's already amplified. So this part here, the extreme right part of this picture, this white thing, metal thing, and also this thing, they are the whole slide valve. They are actuated by this arm here, like this way. So whenever the external flames, also another thing I need to mention is that this engine has a slight compression as in an Otto cycle. So if you want to light the mixture with an external flame source, once you expose that flame source to the mixture here, the flame will be blown off. Although that the flame, actually like the mixture will be light up, but this explosion will actually blow out the flame. So this slide valve in itself, it has a slot, it has a space. There is a combustion gas tube connected to that small space inside this slide valve. So whenever this slide valve passes through this external flame source, the small flame source inside this slide will be lit up, and then the slide moves carrying this, I would call it a secondary ignition flame source, move that source and expose it to the mixture inside the cylinder, and the initiate of the combustion inside the cylinder happens in this way. We will see a video about this. So yeah, this is the chimney This is the chimney which I just mentioned, and this small tube is the external ignition flame source. I'm a bit sorry that the pictures and videos, they are not arranged in in order, so sometimes some mysterious things pops out, but let's just take a look first. So before, Mr. Kobe told me something about this type of ignition. I know nothing about the existence of such a strange but interesting thing. So this thing here is actually a spark plug, but it's differ from the high tension spark plug which we normally use nowadays in natural gas or the gasoline engines. This is a make and break type of spark plug, if you want to call it a spark plug. So this thing functions very similarly, but it's much simpler than the high tension ignition. This is a low tension ignition. So how does it function is that if you ever played with inductors, you will notice that when you connect the inductor with a power supply, and at the exact moment that you break this circuit, a spark will jump across the break you make. So this thing functions in an exact same way. It only needs a DC power supply, normally like 12 volts battery, and a big inductor. And this switch here is where the spark will jump across. It's actuated by the engine's timing system, normally a cam. And the grounded electrode is the engine block itself. And the grounded electrode actually connects to this movable electrode. And the stationary electrode, this one is actually insulated from this whole block of metal. You can see there is a big slot here for the insulation reasons. They just plug in this stationary conductor, and you might be curious at how they make the sealing like over 100 years ago. The answer from Mr. Kobe is this is kind of a mineral. It's mica, as in nowadays capacitors. It's the washers made from mica. From this side is the insulation, also the gas tight side, and this side you also have the insulation and the gas tight. Since you have this slot, combustion gas could get into here. But I would guess that most of the gas tight is done by this one. Sorry for the camera focus. Okay, so most of the gas tight is done by this one, since you have a sealing in this surface here. So yes, let's just move on. So the ignition voltage across the break points here is roughly 800 volts, measured by the oscilloscope. This is an interesting picture. I just took it because in this picture here we can see that the whole block of bearing, the crank bearing, okay, the crank bearing itself is made of this alloy itself. This whole block is a bearing. This is normally we call it the marine end, since like in the big marine engines you can just take this part of the connecting rod away from this bearing without dismantling this bearing, so that you can pull the piston out of the cylinder in this way. You do not need to remove this part to draw out the piston. Yeah, this arrangement is used in like auxiliary engines, generator prime movers in marine engines. And this is their newly acquired Sulzer Crossley, I think it's a Sulzer brother company, and the Sulzer company is nowadays a Wärtsilä company. And this is I'm not sure, but this is the air blast diesel engine. Yes, this is an air blast diesel engine. I think it's 1920s. It's actually very close to the largely spread of use of the solid injection, the Bosch pump type injection in the 1920s, late 1920s, but it's still in the air blast configuration, and I'm pretty interested in this configuration. Actually, I have never seen the actual nozzle, or like they don't have injection pump anyway, like the injection nozzle of the air blast injection. Hopefully I can have a chance to find a spare part next month or the following years. But anyway, this is the air blast Sulzer diesel engine. It's not used in marine, but it's similarly very close type of the marine main engine, and you can see it has a exhaust valve and intake valve actuator arms, rocker arms. It's a 4-cycle engine, and it shows that it has only like 500 horsepower, maybe 5 or 4 cylinders. It's not extremely high power, but it's very interesting and nice engine. This is the crank bearing, the crankshaft bearing, the connecting rod bearing of this engine, the Sulzer engine, and the comparison of this size. Yeah. So this is a hot tube. A man actually is working on this hot tube when we walked in the workshop. So he showed me how does this hot tube looks like. It's made of stainless steel. Yes, and this is actually the external flame source. You can actually see this one here. It will light up another flame in that slide valve, and an old spark plug. By the way, this museum, it has its own oil well and natural gas well. So most of the the natural gas engines burns the fuel from their own well. And this is this picture. It's terrible actually. Like, okay, yeah. In this way you can see much better. But anyway, so it's a 4-cylinder gas engine, natural gas, I mean. And you can see that each cylinder, it has individually 2 spark plugs. And surprisingly, I will let you guess how much horsepower this engine has. So like, surprisingly, this engine only have 150 horsepower. We will see it. So, it even let me do this. It's very interesting. So, anyway, this engine only have 150 horsepower, but it's pretty old, so that's reasonable. And oh my gosh, so this is their gas engine collection. Yes, these are natural gas engines, but they didn't start it up, so hopefully next month we will see it. Yeah, this is also a natural gas engine. And this is the biggest single-cylinder gas engine. Some pistons, rods, and rings. Yeah, some looks like a marine engine because of this handle here, but I'm not sure. Yeah, gas engine again, I think so. Yes, they have the high voltage distributor here. This is a high voltage, high tension ignition distributors. And yeah, this is a pretty interesting. It's a hot bob diesel engine. I think it's hot bob. Let me just make sure. Oh yes. I think so. So this thing here is a hot bob diesel engine. This is its injection pump. It's very interesting arrangement, right? So this is actually, I'm not sure, but in my opinion, I think this is the surface cam configuration. It's a surface cam, like in a vehicle car's air conditioner compressor. It's the surface cam type. Yeah, but this is, anyway, this one here is its start air distributor. This thing is reversible, and I'm not sure actually how it accomplish the reversing. Yeah, I asked them, but they seem didn't do too much things about this engine. But let's guess. So like there's like, if they don't utilize two individual cams, because we have the surface cam here. Oh, I know. I might know how they do this thing. Seems like this is kind of a clutch thing, and this air distributor can be reversed by using two individual cams. This fuel pump here can actually be reversed by a loss movement. The loss movement is a kind of a term in the marine field, but loss motion, sorry. It's kind of just like adjusting the timing adjusting the timing to the crankshaft just by the lost motion anyway. So this is a fuel pump in a closer view, and this is its cylinder head. Yeah. So this is the engine itself. 5 cylinders. Yeah, 5 cylinders. And this is a very big 4-cylinder engine. It's yeah, they didn't start it up, but we will see. These pictures are actually not in good size, but sorry about that. But this is a famous snow engine you might have seen in my videos. It's a double-acting 2-cylinder. So actually, namely 4 combustion spaces and air starting, not reversible, but used for driving the air compressor. And if we take a closer look, this is the actuator rocker arm for the intake. This is the actuator arm for the exhaust, and they share one cam. And because they are arranged in a 19 degrees difference, and it's a 4-cycle engine, we know that actually if you place the two arms in 19 degrees difference, it will actually be 180 degrees crank angle difference. This is actually this is suitable for the 4-cycle engine intake and exhaust valves. So this is natural gas engine as well. This is if you want to call it, you can call it a carburetor. But it's actually a mixture of the fuel gas, which is natural gas, and the air. It's a mixture, and if you want to call it this one the serrato, it's actually, yes, but it's actually adjusting an admission valve of the fuel gas. and you can see the intake to the cylinder, and the exhaust valve is water cooled. At its end there is a water supply pipe into it. I'm not sure how the water came out, but for my guess is that they drilled two water passages inside the worm stem, and one is a water inlet from the end of the valve, and another one is a water outlet, and somehow they drilled it out to the side of the valve stem so that the heated water came out from the side of the stem of the valve from the side. So anyway, but you can see the lubricator, mechanical lubricator for the cylinder, and these oilers, and yeah. Yes. Yeah, this is a igniter spark plug we have talked about. Actually, it's for this snow engine. So yeah, this is the air blast diesel engine, I believe, but it's currently under construction. And this one is the 1903 Rudolph diesel air blast. And more. Yeah, this is natural gas engine. Yeah, this is me with a piston from the Sulzer R&D 90M, but this engine type is guessed by me. They didn't specify it, but from this piston's appearance and its bore, we can get a conclusion. Yeah, also from like this cooling space of that piston, probably Sulzer R&D 90M. Yeah, I just found an interesting, very long fluorescent tube, which is 75 watts. I have never seen such a high-powered one. And Fairbanks Moore supposed piston engines, 5 cylinders, solid injection, 2-stroke. Definitely, it's outpost piston, and this is a room for those. Actually, this one here, and these ones here, they are the external flame ignition type engines, which we have seen in the beginning of this video, and the snow engines, the timing part. A spark plug collection from some volunteer engineers in the museum. It's very old type. I have never seen this before the visit, so very nice. And a hot bulb again. Hot bulb. Let me just take a closer look of it for you. This one is 6 horsepower, and this is a valve stem for a 100 years old natural gas engine. It's the intake, I think. Yeah, this is the external flame engine, but since I have posted a much clearer video of it in my channel, so you can take a look of it. This is a snow engine. Let's take a look, just in case. They are checking that make and break kind of igniter. So yeah, I also have like much clearer video in my channel. So anyway, yeah. So this is that hot bulb, but yeah, as I said, there's a video about it. This one I didn't post any video, but I think. Okay, so this one actually they started by the compressed air, but surprisingly this one doesn't have the air distributor, so you need to watch the timing where you should open that valve to admit the compressed air. It's natural gas powered, so you can see the high tension ignition wire here. I'm not sure if it's low tension or high tension, I might missed it, but yeah, it's natural gas. So what he's doing now is that he's holding down this governor because the speed is not built up yet. He hold down the governor to let the engine do this exhaust cycle. Surprisingly that this intake is drawn just by the vacuum. Like if you have done this exhaust, then the next cycle of intake, the vacuum drawn inside the cylinder will draw in the air and fuel mixture by itself. So this governor just controls if the exhaust opens. If it's opened, then in the next cycle the intake will be down. If that exhaust is not being opened, then the pressure still inside the cylinder will not allow the vacuum to be built up, thus you do not have the fuel admission. Yeah, this is the interesting video I would say, but I would prefer to post a new video about this in my channel, because in that way you will see it more clearly. And what I would like to say is that this engine here is actually let me see if I can let you see this one. Yeah, oh sorry, you are not able to see it because let's just watch it again. So this one here is actually kind of an indicate valve, but it's only used to drain the cylinder. It's a gasoline engine, and during its firing it's kind of very loud. If you stand by it, it's extremely loud explosion. Okay, let's take a look at the interesting thing I was talking about. This is a gasoline engine, but it doesn't use carburetor. It's a plunger injected fuel. Okay, let's stop it. So here actually is the governor part, and this arm here actuates a plunger. This one here, this is a plunger. Plunger admits the gasoline just at the intake passage of this engine. So it has a timed and volume controlled injection of gasoline 100 years ago. Yeah, this is that hot bulb. Okay, this is the last one. So yeah, this is very sketchy video, but I hope you enjoyed this and hope you learned something from it. I enjoyed my trip there so much, and I hope maybe if you want, you could go there to see these wonderful engines yourself. Thanks for watching.